Hey guys, this is Miss Roberge, and I'm here to talk about 2.3 from Unit Launch 4 in Mrs. Schmeel's class. So let's look at what 2.3 says. Different scales. 2 large water tanks are filling with water. Tank A is not filling at a constant rate, and the relationship between its volume of water and time is graphed on each set of axes below. So you'll notice there's 2 graphs here, and those are both representing Tank A. Tank B is filling at a constant rate of 1/2 liters per minute. The relationship between its volume of water and time can be described by the equation V equals 1/2 T, where T is the time in minutes and V is the total volume in liters of water in the tank. So basically, when you look at the equation V equals 1/2 T, that means that the volume at any given time is going to be half of the amount of time that has passed. So if 2 minutes have passed, the volume would be 1, because 1/2 times 2 equals 1. So just to show a little example there. All right, let's look at what they're asking in number 12. Sketch and label a graph of the relationship between the volume of water V and time T for tank B on each of the axes. So we need to get a couple points for tank B, and we have to add it right on to the graphs that we've been given. Okay, so let's look at some of the numbers on here. We have 20 right here. That's really nice and easy to work with. Let's try that number with our formula V equals 1/2 T. So V equals 1/2 times 20. We know that 1/2 of 20 is 10. So that must mean that V equals 10. If we set up a little grid for this, so we can keep track of the points, X, Y is V, X is T, just so you know. So if V equals 10, we know that X equals 20. Let's try to pick another point. Let's pick 40. V equals 1/2 times 40. That means that V equals 20, because half of 40 is 20. So we'll add that over to our graph here. 40, that says 40. And right there says 20. Now let's go add those points on, all right? Let's put the points on the graph. So X is 20, that's this axis. Y is 10. So we're gonna go over to 20 and up 10. Put a point right there. We also said that X is 40 and Y is 20. So we're going to go over to 40 and then we're going to go up to 20. Do you see a pattern here? 60 has to be 30. 80 has to be 40 because it's just half. And then we can put our line on. Not perfect, but that'll work. All right, let's try it over on the other graph. I started with the graph on the right first because it was just an easier graph to work with. So let's make some space here for us. We'll erase some of this stuff. Hopefully you already got it written down. All right, and we're going to do the same with, we'll call this graph A. Okay, so volume equals 1/2 times T. Let's find some numbers that are easy to work with. T, 1. So volume equals 1/2 times 1. That would mean the volume equals 1/2, because 1/2 of 1 is 1/2. So X, Y, 1/2, 1. So we're going to go over to the 1 right here. We're going to go up to 1/2, which is right about here. Let's try it again. Let's try it with 2, which would be all the way over here. V equals 1/2 times 2. 1/2 of 2, V equals 1. 1 goes here, 2 goes here. I go over to 2 on my x-axis, which I got from right there. And I go up to 1 on my y-axis, which I got from right there. Now I can draw that line. So just remember that this graph right here represents a much smaller amount of time. That's why it starts off, it looks so much further apart than the graph over here. This graph represents a much larger span of time. This graph only represents 2 minutes. Remember, this represents 100 minutes. So that should help explain why it looks so different and why this graph seems so far apart. Okay, let's look at number 13. Answer the following questions and say which graph you use to find your answer. After 30 seconds, which tank has the most water? Well, I'm going to use this graph to figure that out because we're thinking about 30 seconds. And this really shows us right here closely where we'd be at 30 seconds. So remember, 30 seconds is 1/2 of a minute. And right about here is that 1/2 of a minute line. So I know that because the green line, remember the green line is tank B, and we'll say that the black line that was given to us is tank A, okay? That means that at this line right here, tank A definitely has more water. You can see that right there. So A. At approximately what time do both tanks have the same amount of water? Now, I'm going to use this graph to figure that question out. And it looks right about here that they really start to overlap a little bit. So that's at about 60 minutes. This is an estimate. I did not draw my line perfectly, as you can see. So I'm estimating about 60 minutes because I see the lines overlap here, and then I just go down and I see that that's at the 60-minute line. Last question, C. At what approximate time do both tanks contain 1 liter of water? All right, let's think about that. So 1 liter of water. Which graph do we want to use to figure that out? Probably thinking we're going to want to use this graph right here. Because again, right here is the 1 liter mark. It's going to be really easy to figure it out. So 1 liter happens for graph A right here, and 1 liter happens for graph B right here. So for 1 minute, excuse me, for 1 liter, tank A took 1 minute. Tank B took 2 minutes. We can see that right on the graph. Now let's do the same thing. We're going to do the same thing, but we're going to do it with a little bit more time. We're going to do it with more liters. We're going to do it with 20 liters. I'm going to go to 20 liters right here, and then I'm going to go over and see what the time was. So it looks like for graph tank A, the time was maybe like 38 minutes. And for tank B, which is right about here, I have to go a little further. That took maybe 45 minutes. All right. I think we figured out 2.3. All right. That comes to the end of the first unit launch via distance learning. We're going to keep up with the videos, try to help you guys out. Let us know, though, if we can do it in a better way and if you need any help. Hope everyone's doing well. Bye.